Engineer, it's an honor for me to introduce Engineer P. Surya Prakash. He's an eminent engineer, consultant, and a mentor, and has made significant contributions to civil engineering. He obtained BTech degree in civil engineering from JNT UK in 1986. He obtained MS degree in structural engineering in 1990 from IIT Madras. Worked for 6 years as design engineer, established Satyavani Projects and Consultants Private Limited in the year 1994. He is also the founder of Smart Infer EST, a trust dedicated to civil engineering to enhance employability and employment. He was president ACCEI from 2013 to 15 and is founding president of PSI since 2013. Engineer Surya Prakash professional memberships are FIE, FACCE India, MICI, MIRC, MIBC, MINSDAG, MIIBE, etc. He is elected council member of the IEI in Civil Engineering Division 2021-25. His authored book on design and implementation of communication towers published by ACCEI Hyderabad. He also authored a handbook on SOP for building construction published by CREDAI Telangana. Engineer Surya Prakash is a guest training faculty to CIRE ESCI Hyderabad on CAD of transmission line towers. He's chief resource person for LEAP's lectures in 56 topic for Smart Infer EST. The CABFADD software developed by him won the ACCE CDC Best Software Award in 2007. He also received Eminent Engineer Awards and President Medal of ACCEI, IBC, iFocus, ECI, Vishwakarma, etc. He organized many workshops and conferences such as WISE 2004, PepsCon, A3C10, MECon 2007, EIA, IS 456, New Vistas, Seismic Design of Buildings, IS 1996, ISIS 1999. Etc. He was a member of expert committee for categorization of seismic damage structures. He was expert committee member for AP government to review projects in irrigation, affordable housing, and capital Amaravati works totally costing about 1 lakh crores. Engineer Surya Prakash participated in international conferences in places such as Singapore, Cosmo Italy, Seoul, Moscow, Singapore, Istanbul, etc. He has guided projects for MTech and BTech students of engineering colleges from IIT Madras, JNTU, NIT, and other institutes. He trained about 10,000 engineers online during the pandemic. Engineer Surya Prakash handled several prestigious projects during the past 3.5 decades. Some of the projects he undertook include affordable housing, residential, commercial offices, IT, industrial, hospital, hotel buildings, infrastructure projects like roads, bridges, metro rail, runways, hangars, logistic parks, leisure theme parks, stadiums, so on and so forth. His prestigious clients include Ministry of Defense, governments of Telangana, Andhra Pradesh, IL&FS, Tech Mahindra, GVK, GMR, BSNL, Idea, Airtel, Tata, Saket, Manjeera, Janapriya, Ashoka, etc. It's an honor to welcome you, sir. Thank you. Over to you, sir.
Yeah, thank you, Sri Nagaraj. And we have shared the biodata in the FDP group, WhatsApp group. And I should also add here, Sri Surya Prakash has always been very kind to NMIT. For the last 5 years, every year when we make a request, he readily agrees to deliver his expert talk and educate our students, faculty colleagues, and others. He has never said no in spite of his very hectic, busy schedule. This academic year, this is the second time he has joined us. I have no words to express my gratitude for this quality of Sri Surya Prakash. He has the great qualities of readiness to share his knowledge and experience with others and remain humble. He is an inspiration to all of us, we the professional colleagues. With this, welcome Sri Surya Prakash, over to you.
Good morning, all the participants and organizers. Thank you very much for your kind introduction, Manjunatha. And today is the FDP on very interesting topic that is design of steel industrial structures. So today I'll be presenting on my experience and some of the case studies of this steel industrial structures, which we have done the designs so far. So you're able to see, sir?
Yes, we are able to see. Please go ahead.
Yeah. So today's my topic is design of steel industrial structures, and some selected case studies I'll be presenting. And so the overview of my presentation is introduction to the topic, and then types of structures in industries. I'll just give a brief details of these types that we deal with in when we deal with design of steel industrial structures. And the steel type of not only material, it is also the sections that we use in industrial structure. And core of the topic, that is design of steel industrial structures. I'll be dwelling on this design. I'll not be getting into the core design methods and all, which is available in textbooks and codes, but I'll be talking about the overall design of these industrial structures. And finally, I'll deal with the case studies of the projects that we have done. I'll explain different types of projects that we have done. So we all know the government of India is focusing on Viksit Bharat 2047. In fact, recently I was also in one of the panels of my college where I studied, where we have laid down the guidelines for improving on the academics and institute industry interaction for achieving this Viksit Bharat. We all know Viksit Bharat aims to achieve $30 trillion economy by 2047. And we all know industries contribute almost like more than 20% of this thing. And the year-on-year growth that is targeted now is 9%, which is very high. If you see so far, year-on-year growth is maximum 8% only. But now from this year till 2047, we are targeting to grow at 9%. So we all know the importance of industries, and we should all participate in working on most efficient and faster construction, because for industries to grow, civil construction will be the very important aspect of this growth. So faster delivery of the projects is one of the very important things. I'll share some of the experiences that we have done in projects, and greenfield and re-engineering. That is two types we'll be dealing with normally. We have greenfield projects of steel. We all know steel is a reusable, recyclable material, and for industries where we normally have a larger span than any of these normal buildings that we deal with. So typically in an industry, we start with a minimum span of 15 meters. That is to facilitate the flexibility in layout of the plant, machinery, and movement of the material and all that. So when we talk about larger spans, it is always advantageous to go for steel because of its lightweight and higher strength compared to other available materials for us. So it's very important today to train the faculty and thus to students for this program, where we update our knowledge on the latest trends and developments in the design of steel structures in industrial buildings. So the types of structures that we deal with in industries are normally, most of the industries so far we used to have only single level horizontal construction. That means a single bay or multiple bays, and length ranging from 100 feet to 100 meters. So, and nowadays we are dealing with some of the warehouses which are some 200-meter by 300-meter kind of without expansion joint. So that is the kind of horizontal structures we are talking about. And in horizontal structures, the spans also will increase from 15 meters to 50 meters, 60 meters. I'll be sharing some of the experiences of such large span. And then in the buildings, we have two types basically. We have the process buildings and we have the storage building. So other than administration and all, which I'll not be dealing today, I'll be dealing with only these process buildings and storage building. Next most important thing in industrial structures is material handling. Because the material has to be moved, we have to optimize the movement of this material, and then also handling of the material, lifting, transporting the material. Next thing in industry is we all know industries we measure in terms of HP, horsepower, total horsepower deployed in an industry. So sometimes we'll have horsepower requirement of 1000 HP in an industry. So the power required will estimate based on this horsepower. And also every industry requires water, process water, and there will be a waste. So we have the structures to handle, generate the power, water tanks and water pump house. All these will be the part of the industrial structure. And waste management, solid waste or liquid waste or air also pollution. We have to handle this in the industries. And then steam, there will be steam required for the process, and then air handling units. We have these, not the, I mean, ventilation air, it is the process air will be required. I'll be explaining a little bit on that. And then every industry requires security. Nowadays, we are dealing with some of the defense manufacturing. Actually, we all know post-Operation Sindoor, India is booming on these defense orders actually from the other country. So we are really, right now, we are dealing with the 6 defense production industries. So once we talk about defense production, there will be a security required. There will be a safety required and access control required for these projects. And
Hello, sir. Voice is not audible, sir. Sorry, Prakash, sir.
Yeah, Dr. Manjunath, I told he's traveling in the car. Yeah, sometimes it happens. I will tell him. Shri Surya Prakash, you are able to hear us?
me?
Yes, sir. You
Hello?
are not audible for around 30 seconds, sir.
Okay.
Yeah.
Shall I go back
Just
and
30
explain about
seconds, sir. Yeah.
security, safety, access, and transportation? Could you hear what I said?
From there, you can start, sir. Yeah.
Yeah. So nowadays, we are dealing with a lot of defense manufacturing industries. Post-Operation Sindoor, India is having many orders from other countries. So in defense production particularly, we need more of security, safety, and access control. And also transportation is required for all the industries. That is for bringing in the raw material and transporting out the finished goods. And also logistics, that is finished goods we have to transport to the logistic parks for further distribution. Next important things in industrial structures are pipe racks, conveyors, and cranes. This is also part of the material handling, but a specific type, a lot of work will be involved in piping and pipe racks, which will be invariably in steel structure. Nowadays, some of the projects we are using precast also, but mostly it is all steel structure. So now I'll be going into the details of these types just to give an idea about the horizontal and vertical. This is a kind of horizontal building. This is about 360 meter long, and about 100-meter wide a project in Hyderabad. And vertical means you have the vertical process in the industries. So we have the structures going up to even 60 meters, 100 meters height kind of structures in steel. So we'll be designing this kind of structures also. So you have both the categories, horizontal construction and vertical construction. Next is the process and storage type structures. So this is a kind of process building. You can see a lot of tanks, piping, and air handling, cooling tower. All this is part of the process industry, and so they'll be very process intensive. Like we have a lot of equipment to be placed, and we have the boilers. So we have to take care of all this and prepare our structural planning to accommodate all the process equipment and the process requirements. So this is the process industry. And then we have the storage building. For example, this is a raw material in a aluminum ore processing unit like a Sterilite Vedanta. So we have a process building of height 12 meters and then span of 47 meters. And you can see the conveyor gallery above. So the raw material comes into this building and we shape the building to take the shape of the raw material. That means when the aluminum ore is placed, it will form the triangular shape. So the structure also we designed in triangular shape. It is structurally economical also. So this kind of storage buildings which are part of the process, and also sometimes we deal with the logistic parts. Next is the material handling. So in material handling, we normally have the material transported by conveyors and pipe conveyors. Pipe conveyors we use when the slope of the conveyor is much higher. Otherwise, we'll have the normal bucket conveyors and belt conveyors. So we have the trestles, transfer houses in this material handling, and coal handling plants is the largest thing that happens, and iron ore handling also will have this kind of metal handling structures. And also EOTs, overhead cranes of electrical operated cranes. So these traveling cranes, this will have the three-dimensional movement of the material. So we have the gantry girders, which we study in our colleges, but in industry, when we talk about the EOT is very important component, capacity of the EOT and the level of the EOT. So that depends on the height handled, the product to be handled at whatever height will be the EOT crane. So you can see these EOT cranes spanning up to even sometimes 50 meters, EOT train capacity of 300 tons also. Next is the process requirement of power, water, waste. So we have the structures required for generation of power, for water storage and water distribution, waste storage and distribution. We have the steam. So a lot of industries require steam and air handling also. So captive power, mostly in industries, we have the captive power generation station, thermal as well as renewable power, and we have substations and distribution cable trays. So the cable trays will again be steel structured, and water treatment plant, storage, distribution, waste collection and disposal, and the steam. Normally for the steam, we have the boiler house. And from that steam, from the boiler house, we also do the heat extraction and again do the generation of power. And the piping required for steam distribution. And next is the air handling. Air filters, we have humidifiers, dehumidifiers, and compressed air requirement in the process industries. So we have the structures related to all these process requirements of the industry. So this is a typical 120 megawatt, you can see combined cycle power plant. So this is how the structures you can see, all components of the piping, the process, everything required in the power generation. And power distribution, you see this very common substation structures which is again in steel. So every industry requires power distribution after the generation. Next is the water treatment, effluent treatment. You have these structures like access platforms and walkways, and then these railing, and even the tanks sometimes we do in steel structure only. Next is the security, safety, access, and transportation structures. So it is a category. We have these entry plaza, security towers, particularly on the boundaries, we have these watchtowers and lighting masts, lighting required for the security reasons, and surveillance and walkways and railing ladders. So these are all the part of the security, safety, access requirements. Next, we normally, every industry will have weighbridge. So, and the barriers, entry barriers for access, cattle guards, these are all in steel structures only we do. And trucks, trailers, and parking, and ramps, we designed ramps for these trucks and trailer, loading, unloading, and material movement. We have these wagons, like railway wagons. We use these wagons for movement of the material. Tipplers, wagon tipplers we have, and ramps, sludge movement and sludge handling, and vacuum pumps, sludge pumps and vacuum pumps for handling the waste. So this is the type of structures in this transportation, security, safety, and access. So these are the, you can see access staircase, access ladders. The design of this and the standards of this for safety requirement also is very important. Next is this security safety. We have this watchtower and air traffic control we call actually in airport. So we have this kind of security towers and crash guards in crash base for firefighting and all. We'll be designing these structures in part of the security and safety. So final important thing is pipe racks, conveyors, and cranes. So you can see these conveyors and conveyor trestles and supporting towers, conveyor tower, and transfer houses. So one conveyor to other conveyor transfer is called transfer house. And pipe racks, you have this kind of simple structures, but very important. Sometimes the height and spans will be very large. So we'll be designing these truss structures for the pipe racks. And the tanks, you can see storage tanks for oil or water. It's a very, very interesting design where we consider only hoop stress and we provide the flexible base for these tanks. We don't go for the rigid base for these foundations because sometimes the tank capacity will go up to 300 tons also. And cranes, you have these yards for the material and the finished product. So we have this kind of framed portals which will handle the material. So we have these material yards and handling cranes. And the conveyor and access, you can see the access staircase to the conveyor system. So this is a process industry where we have conveyors. These are all the conveyor building, covered conveyors, because this is a dry material process. So we cover the conveyors so that it is not exposed to weather. So this kind of conveyor systems also will be there. And we provide access staircases for that conveyors. And this is a conveyor gallery. Typically, this is part of this aluminum ore. Actually, you can see the conveyor gallery design, steel structure for these conveyors, trestles, and conveyor gallery, and conveyor towers and transfer houses we design. So in some of the projects, it becomes a very huge structural steel consumption and structural steel design. And we have this kind of hanging conveyors also. In some of the process industry, where we have the multi-level process, there will be conveyors hanging from the floor and transporting the material. So this kind of, that is a pure tension structure. The supporting system for this hanging conveyor is a tension structure. And these are the conveyor transfer houses we designed. This is a braced structure you can see, and multi-level. You have this conveyor transfer house and access staircase. You can see number of staircases in these conveyor houses also. So the detailing involves use work for steel structures. Next, types of steel that we use in these structures. So we use hot rolled sections and cold rolled sections, formed section. And also we have these built up sections using hot rolled plates actually and flat. We have these pre-engineered sections also. Nowadays, for last 25 years, we are using pre-engineered building where we optimize we'll not go for the trapezoidal sections, we'll go for the tapered sections. Next, we have these pipe sections also. This is a type of section. We have circular, square hollow section and rectangular hollow sections. And in terms of material, we use mild steel, high tensile and super high tensile steel. And super high tensile is more than 420 Newton per mm square. And galvanized, for next is the corrosion resistance in the steel, very important, because some of the projects we have seen extensive exposure to the steam and chemical fumes actually in the project. So we have to take care of the exposure conditions and design the corrosion resistance where we might use galvanized or painted structures. Next is the fire resistance. We all know though steel is very good in strength, fire resistance is weak actually. Fire rating of steel is normally half an hour to 1 hour only, whereas we have to design 2 hour fire rating minimum for any structure. So we have to go for the fire protection also. So these are all the types of steel and protection required. And I'll be sharing some of the examples. So hot rolled, cold rolled sections and pipe sections, what type of sections we use is, we all know we have these flats, angles, round, solid round bars, hexagonal bars, sheet plate, and the channels, C channel, and wide flange, wide beams, and standard beams, I beams, and square or rectangular tubes, pipe round tubes, and T-bars, half round, and half oval shaped bars also, and chamfered bars and rebar. So these are all the steel types we use. And we also use this beam. I have just shown the 3D for the sake of explaining what type of sections we have and how we do the jointing and the channels, angles, and plates. So this is the type of sections, hot rolled. And these are all the cold rolled sections that we use. IS 806, you are all aware. And cold rolled are formed steel structural members. Commonly used shapes are jet purlins we use in roof system actually for supporting the roofs. And also we use the cold formed corrugated steel roof and cladding and floor deck. Nowadays we are using GA deck sheet for composite floor and steel wall panels, that is cladding, and then storage racks. And storage racks also we use these cold formed sections and steel wall studs. So these are all the cold formed section application. Next, we use this built up sections and pre-engineered. So I'll show you that these are all the built up sections. I-beam with the flange plates, I-beam crane girder or gantry girder. Normally we use a built up section with the channel and I-beam. Channel on the top for taking care of the lateral surge, and the box girders. So these are all the built up sections. You can see back-to-back channel and starred angle and back-to-back angle and box channel and the box plated girder. So these are all the types of built up sections that we use. And pre-engineered sections, you can see we shape the member to have the most economical and optimum section. Wherever we have higher moment, we have higher depth, and lesser moment at the base, we hinge the base. means we'll have the smaller section. So these are all the pre-engineered sections. And corrosion this is just one of the project where we had to recommend demolition actually. You can see the level of corrosion in steel members. And this is the fire warehouse in one of the warehouses where there is a fire. Even the very rigid I sections we think they're all twisted and warped actually, you can see. So I'll take a small break here and maybe start in 2-3 minutes. I just reached my office. So give me 2-3 minutes, Raghav.
Yeah, no issues, sir. Please. Yeah. We will have 5 minutes break and meet after 5 minutes. Fine, sir. Yeah, dear participants, he has reached office and he's going from his car to his room. Afterwards, we will continue. Meanwhile, any of you want to exchange any views, you can please do so. And I had also put a message in the group. Just after the presentation of Engineer Surya Prakash, we will have a brief, what I can call as a closing session, where our colleague Dr. Gautam Nair will summarize all the sessions, and also formal vote of thanks will be proposed by our head of the department, Dr. Manjunath. In this session, we also want to have feedback from participants. This feedback is very, very important to us to improve, and also we will know where all we should concentrate and improve. And already I have received some names. I repeat here, if I have missed, you can tell me. And also during the feedback session, some of the resource persons also probably will join. Dr. Sanat Kumar Rajmane has assured that he will be joining us. I don't know whether he has already joined. And Dr. Umesha is likely to join. In addition, one of the participants, Shri B.V. Nagesh, who is MD of Nagesh Consultants, he has also agreed to join and share a few words. We, in addition, have the names Dr. Sridhara S., Assistant Professor, Dayanand Sagar Academy of Technology and Management, Bengaluru, and also Vadiraj Rao NR. I am sorry, I don't have the prefix and the affiliation. Shri Vadiraj Rao has to help me. And these names I will be calling. In addition, we also have the students, Mamata, Harshayam Angadi, and Nandini, who have agreed to share their feedback. Therefore, I'll be calling their names during the feedback session, and please be ready and give your feedback briefly. And then in case any interaction is required, we will definitely have that. And right now, whatever I told for this, you have any response, you are free to respond in the chat box. Anything else HOD wants to add, or coordinator Dr. Gautam Nair or engineer Nagraj wants to add? Please add. And I'm sorry, I missed the name of engineer Nagraj. He also wanted to, I requested him, he agreed to share a few viewpoints of his. I want some messages from the participants in the chat box because of what I told. Please let me see. At least some people coming forward to share their feedback. Manjunatha.
Yes, sir.
Manjunatha Gautam.
Sir.
You
tell
see
me,
the
sir.
chart box, you make managing director, you make that is Sri Surya Prakash. Please make him the presenter.
Once again, yeah, let me joining, sir. I'm at.
Managing director, like that. You see the chart box also.
I'm trying to identify. Yes, sir. Yes, I'm just.
Yeah.
Sir,
Give me a minute.
Yeah.
LATTA managing director.
Okay. Yeah. Got it, sir.
Yeah, sorry, in my office, earlier meeting, it was saved as Latte Managing Director with some client. So,
Yeah, yes, sir.
No issues, sir. You can have your camera also on.
yeah.
If you have no objection.
Yeah, no objection. I'll switch on my camera.
Yeah.
Yeah.
Yeah, you can continue. Meanwhile, I was just telling our participants, we have a brief feedback closing session after your session is over. In case you are free, you can always stay back, sir. Yeah,
no
you
problem.
can. Yeah, you please continue now. We are very happy to see you.
Yeah, thank you. Thank you.
Yeah.
So you can see my full screen now?
Not yet.
Not yet?
No.
Oh. Oh, window I have to go. Okay.
Yes, sir. Slideshow mode, please.
Yeah, I'm doing that. Now?
Not
now
yet.
You can see the full. Not yet.
Slideshow mode has not come.
Now, sir?
No.
There is at the bottom, there is a presentation.
Oh, 1 minute. Stop sharing.
You can press F5, sir, in case.
Oh, F5, huh?
You can start once again. Restart. Share it again, sir.
Oh, share it again. Are you getting it now?
Slideshow mode, not yet.
You're seeing my screen, full screen?
Yeah, yes, we are seeing the screen.
Only slideshow, it is not changing.
Yeah. Dr. Manjunatha, you have any quick suggestion, or we will go ahead like this?
Yes, sir. Yeah, no. Sir, what you do, you just share the entire screen, then it will be visible, sir. I think you have shared only PPT. You can share entire screen.
I'll go back to that. Share. Oh, entire screen. Okay.
Yeah, yes, sir. Then
so share entire screen
and click on the wall. And now you switch on
F5.
the presentation. Yes, sir. That presentation icon also you can press.
Yeah, now you are getting.
Yeah, yes, sir. Yeah, clearly.
Now it's okay.
Now it's fine,
perfect,
sir.
sir. Now
Perfectly
it is
fine.
perfect. Please go ahead.
So now we have come to the core of our topic today, that is design of steel industrial structures. So in the design, what are all the things we have to consider while planning and doing the design is basically for all steel industrial structures, the most important loading that we have to consider, which is critical, is wind. And then we have these vibratory loads due to equipment, process equipment. And then we have the equipment loads and UOT crane loads, and then any other material handling, pipe racks and cable trays and all that. And then normal dead load and live load as per the IS 875 we consider. So these are all the design aspects that we are considering. And so the wind loads, when we consider, we have to consider the disposition of the layout, our various structures, their heights, and then consider the topography factor and drag coefficients for the structures. Main important thing in wind loads consideration is percentage of openings in the structure. That is whether we provide lowers or windows and lowered windows. These are all the types of openings we provide. And sometimes we have the canopy-like structure. So considering the proper drag coefficient, proper force coefficient for these structures is very important. So IS 875 gives various coefficients for 20% opening, 50% opening, and more opening. So and mostly the roof sheeting and cladding will be getting the uplift in the roof sheeting. So the zoning of these roofing also, eaves zone and gable end zone and the ridge zone, there are different pressure coefficients for the wind. So that's very, very important. And on the cladding, we have the windward side positive wind, and leeward side we have the suction. So we'll be applying even the suction forces from the wind on the structure. So it's very, very important understanding the pattern of the wind loading and application of the wind loads in the correct position. So the wind load conditions itself, sometimes in the industrial structure, the total number of loading combinations will go up to 500 even. So wind in different directions, wind application. We have to make it critical for various conditions. We have to also consider the disposition of these moving loads, crane loads, and we have to position the loading such that most critical loading is considered in the design. So this is the most important aspect in the design. And next we have these cranes, you can see. So when we have these multiple bays and multiple cranes, we have to consider the maximum load positions. So we'll have the multiple conditions. So two crabs coming close to one column. So like that, for each column, for moment criticality, we have to have one condition, and for actual criticality, we should have another condition. So we'll be taking all these loading combinations of the EOT crane and the wind loads. Next is the structural system. In the structure, you can see those sag rods that is being shown connecting the purlins. Nowadays, invariably, we are using the jet purlins, which are depths varying from 250 even 300 depth purlin. They are all light gauge sections, 2 mm thick sheet and all. So we need to have lateral stability and reduce the lateral buckling length for the LVR ratio. So because that is critical for the allowable stress in the purlin flanges. So we need to provide these sag rods, and positioning the sag rods, whether we position all sag rods at the top, all sag rods at the middle, or we stagger. Some alternative sag rods support the top of the purlin, near to the top line, and the alternate sag rods we support to the bottom flange of the jet purlin. So this is very, very important for the purlins. Then once we stabilize the purlin design, then we have these wind bracings in the structure. We also call sometimes rafter bracing. So you can see the
gable end side bracing, and this is a wind lattice we call, and U side lattice, and both the U sides lattice. So this is very, very important for the stability of the structure, because all these industrial structures primarily are braced structures. Mostly we consider braced structures which are economical. Sometimes we'll not have space to provide these bracings in the structure. Then we go for the moment resting frames. When we go for the moment resting frames, you are aware the sections will be very heavy, going up to the depth of 1.5 meter deep beams and all. Even 2 meters deep beams we have provided to get that moment resistance. So this is very, very important aspect when we plan these industrial steel structures. Next is the equipment. You can see the complexity of the equipment that is placed in the industries. So you can see the bracings at the top in this picture, in the rafter bracings, and we have these windows also. We are providing lattice, though because these tie runners, cladding runners, we cannot make it to moment resting. So we provide these bracings at the end and at the windows also. And the equipment floor loads. These are all vibratory loads, and floor vibration is a very, very important aspect. We have to check whatever the natural frequency we consider, whatever force vibrations we consider. So we have to see that the force vibrations are beyond 0.5 to 2 of the natural frequency of the structure. So we do practically these checks in the structure to make the structure less vibrations, prone to less vibration. So we even provide these vibration monitors in the floor, and we record the vibrations to see the health of the structure. So we record this and keep checking periodically these vibration levels in the structure. And another I learned this when we have done about a project about 28 years back. The IS code gives how to check without the equipment. So you can check the vibration level of the floor. If the vibration you feel is below the ankle, no, you need not think about it. If the vibration crosses the ankle and below the knee, then you have to inform the building manager. The workers, this is very important to keep this kind of picture in the industry, so that sometimes we may have some vibrations unexpected in the structure. So we have to make aware all the workers for their safety. And if it is crossing above knee, it's an inform emergency rescue team. And if it is above hip, use emergency escape falling. Actually, this is given in the code because for the people we can't tell the frequency level. So this is the best way to observe the vibration levels in a structure. This is applicable to even in kind of in times of earthquake actually, or wind vibrations. Next is the lighting, ventilation, heating, and air conditioning. So this is the, you can see artificial ventilation we are doing, and the skylight nowadays we are providing this strip lighting. This is the during the day without any artificial light actually. You can see the lighting level. So lux level, we design the lighting in the industries, and also we provide the number of air changes with the artificial ventilation systems. This is not air conditioning actually. It is only the controlled air conditioning for a electrical assembly building actually. So next is the heating. This is a structure we have done in a location where the temperature is minus 30 degrees, lowest temperature. So we do the heating of the building also. So in I'll show you some other project where the entire industrial process is dry process. That means we have to install dehumidifiers, and we have to keep the temperature above normal, and also the condition dry. So this is the kind of requirements we have these industries. Next type of structures. We have these trusses, all truss elements. We have this fixed end or hinged base, and we have the portals and spatial structures. So these are all the structural systems we use in industries. So this is a truss. We all know types of trusses and the detailing, level of detailing we do in the trusses. You have the purlins, you have the roof sheeting, you have the ridge monitor, monkey roof sometimes, and we have north light roof sometimes on the ridge, and we have this gutter at the eaves level for draining out the rainwater. So it's a highly detailed structure. We have to have complete knowledge of all these finer things. We have nowadays how to fix the slope of the roof. Earlier days, we used to provide 1 in 4, 1 in 5 kind of slopes for asbestos sheet, whereas now with the galvalume and color coated sheets, we are using slope 1 in 10. And with the what you call seamless roofing, we are going for roof slope of 1 in 20 also. It's very advantageous because the change of slope, we make it much flatter in case of seamless because there are no joints. There is no lapping of the sheets. So that is very advantageous. And we design the stormwater level depending on the rain, and also design the gutter and downtake pipes considering this. And this is a portal with composite deck slab. This is a type of structure. You can see we have a 10-meter high floor because of the process equipment and all. And above we have the real process. So we made the span half, 12 and a half and 12 and a half. And above we have 25-meter span. And you can see the ridge monitor. This is a natural draft ventilation. When we provide the ridge monitor, it creates the natural draft from the windows we have here. You can see we have 3 levels of windows. One is openable windows, one is top hung swivel windows, and the other is the lowered windows. So this will create the natural ventilation. And I have visited this plant even after 10 years of construction. Whatever design parameters we have considered, they're all working very well, including the corrosion protection. So, and this floor level, we have equipment. So we have gone for the composite deck using the MS profile deck those days. And then we have used the shear lugs for giving the composite action with the minimal reinforcement in the slab and minimum thickness of the slab also, only 90 mm, even for the industrial roads. That is the advantage of composite deck. And these are the spatial stress structure. That means these are not linear truss or linear portal. It will be a spatial. All 3 directions we have the truss element, and we have designed that type of structures also, where we have spans, larger span requirement in both the directions. Normally, we have a larger span, 25 meters in one direction. Other direction, we can have columns at 6 meters. Suppose we need a spanning of, let us say, 50 meter by 50 meter. So then we go for this kind of spatial truss system. Next is the joints. Very, very important. Normally, for erection, we use bolted connection only, but we can have the factory welded structure. Normally, no site welding is permitted. So these are all the bolted joints. We have the chain bolting, we have diagonal bolting, and we have slotted bolting, where the tolerance required is more for erection. We go for this slotted bolting. And these are the weld symbols. We all know types of welds: fillet weld, square butt weld, single V butt. And these joint designs and the indication of the welding as per the code is very, very important. This is a language between the welder, fitter, and the designer, detailer. So it's very, very important for students to learn this kind of practical thing. It will help in the practice very well. Next is the static and dynamic analysis. So as I said, vibration control in the structure is very, very important. Vibratory loads we have. So we consider the vibration levels of the equipment and design the structure to have the natural frequency beyond the vibration level by 0.5, less than 0.5, or 1.5 times the natural frequency. So we do even the isolation of the structure. This is one of the large structure we have done with the total isolation and damping. Its length of the structure is about 150 meter, and width of the structure is about 15 to 20 meter. So we have done the isolation on all the sides of this structure and damped by isolation. And next is the slenderness effects in the structure and stiffness. When we design any steel structure, the most challenging thing in steel structure is controlling the buckling. And so the slenderness. So we have this kind of columns we have designed even using the battened columns or laced columns, and with the stiffeners in the base and stiffeners at the supports with the moment connection and all that. So now I'm just coming to the case studies, last part of my presentation today. That is various types of industries we have done, and I'll be showing the case studies of those buildings. I'll not get into micro level detailing of this. If anybody is interested, I can share separately, but today I'll just cover the overview of these case studies, different types of industries. So when we talk about industries, we should all know that there are three types of industries basically. Heavy industries, that is mining and heavy engineering, petrochemical and all that. They come under category of heavy industry. We have medium industries, that is medium scale engineered industries, process industries and all. And we have small industries. In the medium, we have even food processing nowadays, large food processing industries which we have done. And defense manufacturing also comes under medium actually. Next is the structures that we use for logistic parks and warehouses. They're all also nowadays very large requirements of these warehouses due to companies like Amazon or Flipkart kind of companies. We have done for them also. And ITC, Unilever, they have the logistic locations with every city. In fact, you will be surprised, Amazon alone in the last 5 years have added warehouses worth 5 million square feet in the last 5 years. So every year they're adding 1 million. We have the last mile connectivity, we have the distribution centers, we have the city logistic park and all that. So this is another major thing happening. And next is the depending on type of production, that is pre-engineered building or fabricated structure. So I'll share some of the case studies of PBs and some of the fabricated structures. And then I'll also share food processing industries and engineering industries. And next, the power and turbine generator buildings. And next, I'll share some of the cases of conveyors and cranes. So these are the case studies I'll share. So this is a mining. We have done iron ore and aluminum ore, and even some of the petrochemical complexes, heat recovery buildings and all that. So heavy industries mining, you can see the level of detailing that we do for the structure as well as the joints. And this is a medium industry where we have done the portal kind of structure with all the access platforms and foundations, machine foundation, equipment foundation. This is a drawing of an edible oil refinery actually. Next is the small industries. This is a tobacco processing industry for ITC. We have done with the Northlight Group, and we also have done ancillary structures of automobile industry, with robotic machines and all. They all come under small industries. Next is the logistic parks and warehouses. So this is a logistic park we have done for ITC again in Andhra Pradesh. Almost like 30 years back itself, we have done this automatic stack recovery system. That means they get the tobacco pallets, which will be stored automatically. This is all unmanned handling of the material. So there will be stack recovery crane that will be. So what we have done here is we have used the stacks to support the structure actually. The stack which is storing the material itself will support the structure. So the challenge there is the tolerance or the sway effect in the structure which is to be limited to 5 mm, because stack recovery crane, the limitation is if there is a deformation more than 5 mm, then stack recovery crane cannot function. But we are using the stack for supporting the structure. So the wind effects we have to design, give the stiffness to the stack such that, so we saved use in that. So that kind of structures also is possible. Next is the warehouses. You can see the canopy for loading, unloading bay here. Normally everything will have, and here you can see the safety cable. When people go for maintenance onto the top of the roof, we have provided the safety cable here at the end of the building. And the access staircase with the railing, toe rail, and knee rail and handrail, we have provided this. So these are all the types of warehouses. Even in warehouses, we have this water requirement and power requirement, air conditioning. Sometimes we have cold storage. So and firefighting. Firefighting also is very important. Fire sprinklers we provide in warehouses. So this is one of the large warehouses we have done in Vapi near Mumbai, which is a single building of 7 lakh square feet. So that kind of challenges also we get. And this is a PPE warehouse where this is the building I was talking about, 200 meter by 300 meter, without the bracings in the between the columns. They're all moment connection and the span of 50 meters and 20 meters cross span. So that kind of challenging structures also we need to do. This is the warehouse, and you can see the wind bracings along the columns. In the rafter level only we have provided the bracing, but in the columns there are no bracing. So it's all moment resting frames. Next is the types of PEB and fabricated structure. So this is the pre-engineered building structure. Here you can see we have the fixed base and rigid joint at the top and hinge in the span. And cranes also we have. So we have the stepped column for supporting the gantry crane. So this kind of PEB structures also will be using for the industrial steel. And next is the fabricated structure. So this is what laced column I was talking about. We have done the battened columns, laced columns, and laced rafters also, and the boxed rafters. So this is a canopy with pipe. We have done fabricated structure. And next is the food processing and engineering industries. So this is a food processing, palm oil refinery. So this is a complete greenfield project we have done. Food processing, that means getting the palm olive fruits and processing them, handling the palm olive fruits, and then processing, extracting the oil and refining the oil, all at one place. So this is a kind of food processing. We have also, this is the engineering industry, like our building manufacturing. Kirby. This is a Kirby plant. So this is how typically automobile also comes under engineering industry. So we have, we call it medium scale, but they're also quite large in terms of size. And we have the steel raw material to finished product of steel painted within the same building itself. In the process line, we designed this building. Next is the power and turbine generator buildings. So this is a power plant in Doran we have done. It's a combined cycle power plant. It's a, though it's a masonry you are seeing outside, but roofing and all is steel we have done. And the turbine generator foundation also we have done in frame structure. Next is the conveyors and crane. So here you can see this is a Mahindra automobile industry where we have these multiple cranes, and lighting is handled through lowers and skylight, and then conveyors, conveyor galleries, conveyor trestles, and then we have these conveyor towers and transfer houses. So this is the storage for the raw material in the aluminum ore. And then we have the stack chimneys for the support, for the sake of air handling and disposal of waste air. So this is very, very important structures we do in steel. We have concrete chimneys also, but here it is a steel chimney with the complete detailing of the base and splices. And these are the plant buildings in the palm oil refinery we have done. And we designed these motorized doors. I was talking about heating from minus 30 degrees to plus 20 degrees. In such buildings, we have to have the motorized doors so that the loss of heating is minimized. So we have designed this kind of motorized doors of 30-meter wide also. And the base plate and anchor details, this is the first thing in any steel project will be required to give it to the client. So the first thing is template and then anchor bolts and then the base plate. So these are the drawings, foundation drawing, which will be releasing in the first thing. And bracings, I was talking about the wind bracings at the eaves level, valley, ridge level, and gable end side. So we need the bracings to stabilize the structure against the wind in all the directions. So this is the cross section. You can see the single valley there and two eaves and two ridges. So this is the kind of detail. And the moment connections. Here, because there are no bracings between the column, we have designed the moment connection. During erection, any steel structure, the erection sequence and erection methodology is very important. Unless we have the complete erection methodology and sequence, our design will not be complete for the industrial structures, particularly the steel structures. So we need to consider sometimes the temporary supports during erection. There are cases where we had hinged bases. We introduced temporary fixity during erection because, if all are hinges, it will not be a stable structure. So we have to introduce sometimes temporary fixity at some place to make the structure stable. So this is a building after completion and before completion, and the canopy structure in pre-engineered building only, and facade joinery, lighting and ventilation in one of these ITC projects we have done. We have used the staircase for lighting. You can see the glazing for aesthetics, and at the top lowers for the ventilation. So we have created the natural draft there. And joinery, you can see the windows, that is swivel windows and lowered windows and openable windows. It's a 20-meter high building, which is operated also. So this is the overall view after completion of that building. And you can see the top structure that is in steel for the lowers, because for natural draft, you need the tower. In Dubai, you see this kind of thing. So we have used that for the sake of maintaining natural draft, and also roof monitor. This creates the wind flow naturally by its shape, venturi action actually. So that kind of structures also we design for the ventilation. And during erection, you can see this is the composite floor deck with reinforcement. After deck is laid, we provide the reinforcement and then concrete, and then do the roof sheeting later at the top. So these are all moment resting frames. You can see there are no bracing, and we have given the moment connections. And this is the composite deck slab plan. So flooring plan also, and this is the framing details of the gable end with partial bracing, and this is the gable end cladding detail, and we have this composite deck floor. And the braced roof here at the rafter level, bracing we have done at the gable side. And this is the gable end detailing. You can see the cladding supported with the bracings. So it becomes a latticed kind of garden. And the facade detailing, you can see the glazing, what level of detailing. That time we didn't have pre-engineered buildings, so we have done the complete pre-engineering, considering the available materials, flashings and all that. Connection details, that is the moment connections between the eye girder and box sections, and you can see the drainage, round tech pipes detailing at the gable end, and this is the gutter detail. So these are all many projects that are completed by us in power, electrical assembly. This is a completely pre-engineered with a standing seam, 90-meter by 90-meter building. And inside is this with the skylight and artificial ventilation. This is the field services. That means the cables, metal handling, all that. And I'll just run through these some of the projects that we have done in the power plants. Feed services is all about material transportation, material feed. And this is the pipe rack supporting structures. You can see the height of the pipe rack and the chimney. And so these are all the steel structures that we have done. And this is an engineering industry, again, tower manufacturing and the combined cycle power plant. And Guntur, this is that tobacco company we have done with Northlight Roof. And you can see the access ladder and safety provision. Some of the, this is edible oil refinery in Kakinada that we have done with the pre-engineered. And this is Mahindra Steel Company. This is a small industry, but ancillary of automobile industry. So this is the completed photograph. And this is engineering industry steel products where the welded wire fabric is manufactured. So these are all the, and this is a steel rolling mill and steel fabrication unit, which we have done. And this is the Sterlite Vedanta mineral industry, oil storage tanks. And this is again engineering industry without purlins and rafters. We have used the roof sheeting as a shell shape. Okay. So this is edible oil industry, and this is a spinning mill that is a fabric. And this is a power plant, gas turbine plant that we have done. So this is the power plant. We have the switchyard, and we have the storage warehouses. These are the warehouses and firefighting equipment and sprinkler system are a large area. And this is the multi-level logistic park for Gati and warehousing for Bihar state. We have done the warehousing, seed storage system, and water treatment plants, and the effluent treatment plants. And so these are all the drawings that we typically make for these industrial structures. We have general arrangement drawings, we have erection drawing, we have the fabrication drawings, shop drawing. This is the level of detailing that we have to do for these projects. So I'll coming to the end with these drawing detailing. These are all general arrangement drawings that I'm showing now. Elevation and section, in making plan. Sectional elevations, floor plans. Flooring also we have to detail to the very close level. And lowers, you can see lowers for ventilation that we provide. Connection details, warehouse drawing, and refinery tanks, their foundations, powerhouse, pipe racks. This is the pipe rack detailing. And chimneys, foundation, steel chimneys, and conveyor systems, foundations, crusher house, and all. So this is what I wanted to share today. If you have any questions, you can put it in the chat box or mail it to me later if you miss, and communicate to me. And also, all these lectures are available in my YouTube channel. In my name, Ponnada Surya Prakash is the channel. So I thank Raghavaji for giving me this opportunity, and hope this interaction will be useful to you for our objective. Thank you.
Yeah, thanks a lot, Sri Surya Prakash. As I already told, we are very, very grateful to you for always agreeing and joining us, and you have never told no. And it was mind-boggling to see the diverse structures you have designed and their huge number. I am at loss of words, and I am sure all the participants also feel the same. There are quite a good number of questions, and some of them are in the chat box also. And I will go through them one by one. And we start now, sir. Question number one. And meanwhile, I request the participants to please post the questions in the chat box. We will take them one by one. You mentioned the different types of steel used in industrial structures. Do we have all these indigenously available, or are we importing some of them because of necessity?
Actually, all the types that I have shown are available in India. We are using indigenous sections only. Only super high tensile steel we have to import. It's not available in India. Otherwise, high tensile and mild steel, hot rolled sections, and all those built up sections that I have shown, they're available in India.
Yeah, when you told the high strength, the next question is about that. Do we use high strength steel in steel structures? If yes, what is the range of strength?
Actually, in some of the structures, clients specify not to use high tensile. Otherwise, in most of the private projects, we are using high tensile steel in built-up sections as well as pre-engineered buildings also. That the PP warehouse that we have designed, we were not allowed to use high tensile steel, so we are designed with mild steel only. We have done some of the projects funded by foreign countries, agencies. They specify super high tensile steel so that we utilize that country's steel. So there we have used super high tensile also.
You told you were not allowed to use high strength steel. Why, sir?
It is a safety requirement for the client because by using high tensile, sometimes the structures can become slender, particularly when we have these large spans and all. Actually, it is advantageous to use high tensile, but due to various reasons, they specify in the contract not to use high tensile.
The next question.
Particularly petrochemical companies.
Yeah, I go to the next question. Does code allow use of light gauge steel for structural applications?
Yes, we are using light gauge steel for structural applications also, but not the main structure. We are using for secondary structural elements like purlins, girts, and all, and built up frames for up to nominal spans, not very large span. We are using light gauge steel.
The next one is from Dr. Manjunath Ayal. We see that in the chart box also. Sir, in the kind of structures we have shown, would wind loads be critical or seismic loads?
Actually, steel structures, we know seismic design is all about ductility, and steel has very good ductility. I have checked in many of the projects. In fact, when we did one project in Gujarat, we have checked the comparison between highest seismic zone and highest wind zone. The seismic loads contribute to 1/5 of the wind loads only because of the light weight of the nature of the structure. The seismic forces won't be governing the design.
Yeah, the next question. You mentioned the need for considering around 300 load combinations. How were we considering so many combinations a few years back when we did not have the luxury of computing power?
That's a very good question. Even people have designed structures even when there is no calculator with the slide rules. And my guru has given me Batten calendar, and some of the books, Germans have developed even the coefficient for all the types of portals, depending on the height to width, the span ratio and all. So you can directly take the force coefficient, design the main structural elements with those force coefficients. People used to be more engineers those days. Now we are more computer engineers nowadays. So because of the luxury of high computing power and all, we are using. In fact, if you ask me to design, I'll not design with 500 cases, definitely. I know which case will govern, and I design that first manually and then ask my engineer to check with that. But when a junior engineer designs, he will put all the combinations as per the code and take the maximum out of that and design each element for the governing case.
Yeah, I go to the next question, sir, again by Dr. Manjunatha. It is in the chat box. In buildings where vibration is present, does fatigue pose a problem, sir?
Yeah, actually, in some of the machine foundations particularly, we refer to institutions for fatigue tests also, some of the structures. But most of the industries that we have done, we didn't go for fatigue test, but we take the coefficient for the fatigue, depending on the number of cycles and operating machine that we have. We only control the natural frequency of the structure, considering the vibration frequency of the structure.
The next question from the chat box by Anas Beg. Sir, what is the criteria for providing fly bracing? Some structures skipped it for roof purlins.
Fly bracing.
Yeah, fly bracing.
That is wind bracings that we are providing in the purlin, rafter level, no? Is it the same thing?
You can see in the chat box also, Anas Beg, 1228, at the time 1228. Sir, what is the criteria for providing fly bracing? Some structures skipped it for roof purlins.
Oh, huh? Yeah, this is wind bracings only basically. Fly bracing is calling. But whenever we have to shift that, we have to provide the moment resting joints, provide tie beams and then moment resting joint for that. But we cannot avoid these bracings in the rafter level basically, because otherwise the structure will be subjected to torsion without this bracing.
The next question, do spatial trusses take away the free operational or functional space available?
No, spatial structures gives more space actually. As I said, we use the spatial structures when we have the large span requirement in both the direction. That means suppose a client comes with a space requirement of 50 meter by 50 meter. Then I can't go for columns in between, or I can't provide 50 meter span both ways actually. So I go for spatial structure only, two-way spatial structure. It can be by using nodes or it can be by using welded joint. We have done whatever I have shown, we have done using welded.
The next question from the chat box from Dr. Manjunatha L. For the design of connections, do you use any software or is it done manually using first principles?
Yeah, actually we have spreadsheets. We use the spreadsheets for the joint. There may be some software, but it is better to go with manual calculation only because joints are very critical. We have to understand the erection sequence, erection mechanism, and then consider the forces that are required for designing the joint. One is erection joints, other is the actual main joint.
Before I take up the next question, I request the participants to see the chat box and fill up the feedback form, please. Yeah, the next question again from Dr. Manjunatha in the chat box. In the multi-story structures you showed, what is the type of flooring system adopted?
Yeah, actually, olden days, it used to be checkered plates or grated gratings, actually. It is a steel floor only we used to use, but nowadays, we are going for composite deck floors. Whatever I have shown, two buildings today, some of the levels we had composite deck and some of the levels where we have the process requirement, we have gone for the checkered plate or gratings.
The next question from the chat box by Vadiraj Rao. When do we go for releases in the members while modeling in StatPro software? Kindly explain the reasons.
Actually, steel structures mostly we design as shear connections. Actually, shear connection means we transfer only the shear to the column. And in such cases, if we are modeling the frame using frame element, because I-beam, in the span we need the moment and shear also, we release other forces like for truss also, conventionally and manually when we do, we have one side hinge and other side roller. So for the sake of roller, we have to release the horizontal axial force. We provide the roller to not to have any axial force transferred to the truss, basically because truss is only a moment resting element. And it transfers the shear only and not an axial force. And we allow the rotation, so we release the moments in the truss portals. And then we release the axial force within the plane and out of plane also. So only shear will be transferred to the column. That is, if you have Fx, Fy, Fz, or Rx, dx, dy, dz, Rx, Ry, Rz. So we release Rx, Ry, Rz, and dx we release, only dy we restrain, and dz also we release. Because we have dz, another member in the tie beam. So like that, we release on one side. On the other side, we keep dx and dy restrained, and dz and Rx, Ry, Rz we release. So that's how we do it. And whenever we go for the hinged base, in the hinged base, we release all Rx, Ry, Rz, and we restrain dx, dy, dz.
Next question by Dr. Gautam Nair in the chat box. Thank you, sir, for those valuable case studies and practical insights. Wish to share a small practical-oriented query. In a real project, when we are designing a steel industrial building with heavy equipment and overhead cranes, and midway the client upgrades to larger machines, adding unexpected loads. How to practically handle this without major delays or redesign costs?
If the structure is already fabricated and erected by the time we get the change, so we will introduce the additional members or additional strengthening to the existing structure. We have done that. In many cases, it happens. Change is a constant thing in every project we do. Right? From the beginning, before the commissioning, we get many changes from the client, as mentioned by you. And we keep handling that either by retrofitting or by changing the structural system to handle that additional loads and additional requirements.
I have two more questions, and meanwhile, Dr. Gautam and Dr. Manjunatha can just see the chat box and let me know whether I have missed any questions. Now, I go to the last two questions here. The one is by Anas Beg. Sir, are the purlins or girts designed for flexion?
Yeah, actually, purlins and girts are basically moment resting members only. We have the continuous support for the purlins. We always detail such that there is a moment at the support, continuous moment, so that we take the advantage of that WL square by 10 and the span moment to WL square by 20 kind of thing, 16. So we design, actually shear is not critical in purlins. It is only the flexion. They are flexural members, purlins and girts.
The last question I have, again from Dr. Vajiraj Rao. Sir, what kind of precautions were taken to handle the temperature stresses in these structures?
The building I have shown 200 meter by 300 meter warehouse, we were not permitted to have any expansion joint or temperature joint. So that structure we have designed considering the temperature variation of 30 degrees, 30 or 20. 25 degrees actually. So we have introduced the temperature load case, and whatever stresses we are getting in combination with temperature, wind, and live load, we have designed the structure for that combination. So we can introduce the temperature condition in the analysis. Even RCC buildings nowadays, most of the cases we are required to design with the temperature, but steel structures are more critical for temperature condition. Definitely, we have to consider.
Yeah, Dr. Manjunatha and Dr. Gautam, can you assure me that we have taken all the questions?
Yes, sir. I think all the questions we have taken.
In case I have missed any, immediately the participant can put again in the chat box. We will do that. And sir, once again, we are very grateful to you. Thanks a lot. And if time permits, please stay back for a brief closing session. And in the closing session, I do not know whether you still remember them. 3 of your IIT friends would be here. One is Shri B.V. Nagesh, who is MD Nagesh Consultants, Bangalore. Another one is Dr. Umesha of former SCRC, who is now in Vidyavardhaka College, Mysore. And also Dr. Sanat Kumar Rajmane, who is now a professor of practice in IIT Dharwad. And all of them have told that they will be joining now. And if they have joined now, our Dr. Gautam and Dr. Manjunatha can see and unmute them also. And you will have the pleasure of meeting them online. I think that was sometime 85, 86, I think. Yeah. Long time.
87, 90, I was in IIT.
Yeah.
So maybe, Rajmane, I met him recently also. In fact, and of course, Umeshaji, we keep meeting online and discussing. For last 30 years, I am in touch with him. And Nagesh, of course, is my colleague, professional colleague. And we also keep interacting.
Yeah, Dr. Sanat Kumar Rajmane, I saw him in the list here. He has joined, and we will listen to him during the next closing session. Thank you very much, sir. With this, we have completed all the technical sessions. Now that all technical sessions are over, probably I am the most relieved person. My sincere thanks to all the resource persons. Every one of them is gem of a friend, always ready to help and support and share their knowledge. The participants were top-class students. I am very proud of you all. Assuming this FDP gathering as a classroom, as a teacher, I could not have dreamt of better students than the participants of this FDP. My sincere thanks to every one of you. I thank my wonderful colleagues who always take all the burden on my behalf. Now I hand over to Dr. Gautam Nair to give a brief summary of the entire FDP. Over to you, Dr. Gautam Nair.
Thank you, sir. Am I audible?
Yeah, very much. Please go ahead.
Okay, sir. Thank you for giving me this opportunity to deliver this closing session by mentioning the key highlights of our FDP. Good afternoon, everyone. Before we move to the closing session, I would like to briefly present a summary of the key highlights of our 5-day faculty development program on advanced analysis and design of steel towers and industrial structures. The program began on day 1 with a warm welcome address by our HOD, Dr. Manjunatha L, setting the tone for an enriching week of technical insights and knowledge exchange. All the sessions were seamlessly coordinated and guided by our convener, Dr. Raghavaji, professor at NMIT and former chief scientist at CSIR SCRC, Chennai. We are happy to note that throughout all 5 days, we had the active engagement of over 70 participants from academia, industry, and research. On day 1, Dr. P.K. Umesha, professor at Vidyavardhaka College of Engineering, Mysuru, and former chief scientist at CSIR SCRC, Chennai, delivered an excellent session on structural analysis and design of telecommunication towers, enhancing stability and efficiency. He explained in detail the fundamental design principles governing telecommunication towers under wind loads and serviceability limits. The session included practical considerations for ensuring structural stability, member connections, and maintenance aspects for longevity. On day 2, Dr. Sanat Kumar P. Rajmane, professor of practice and advisor at IIT Dharwad, spoke on planning and designing a steel warehouse building. He shared step-by-step methodologies for modeling and analysis of large-span steel warehouse structures. Participants gained valuable insights into practical codal provisions, construction sequencing, and detailing aspects critical for efficient execution. On day 3, Dr. S. Vishnuvardhan, Senior Principal Scientist at CSIR SERC Chennai, gave an in-depth lecture on fatigue and mechanics of fracture in steel structures. He connected theoretical fatigue life prediction with real-world examples from laboratory testing and field inspections. He also emphasized how fatigue and fracture assessments influence maintenance planning and retrofitting strategies for steel structures. Coming to day 4 included 2 highly engaging sessions. In the first session, Dr. Mahendra Kumar Madhavan, professor at IIT Hyderabad, spoke on planning aspects of PEB buildings. He highlighted how effective planning of pre-engineered steel buildings can optimize cost, material use, and speed up construction. He also discussed practical design challenges when PEBs are used for heavy industrial applications subject to machine vibrations and vehicular movements. In the second session of day 4, Dr. M. Selvaraj, Joint Director and Head of the Mechanical Engineering Division at CPRI Bengaluru, delivered a session on design and testing aspects of power transmission line towers. Participants were able to relate the theoretical design aspects to full-scale prototype testing carried out at CPRI. The session provided an excellent overview of practical testing challenges, failure modes, and design improvements based on test results. On the final day, that is day 5, Engineer P. Surya Prakash, founder and managing director of Satyavani Projects and Consultants Private Limited, Hyderabad, concluded the technical sessions with his talk on design of steel industrial structures, selected case studies. He gave a comprehensive overview of different categories of industrial structures and the unique design demands for each type. Through case studies, he demonstrated practical solutions, lessons learned, and the importance of coordination among design, fabrication, and erection teams. Following these sessions, we will now have vote of thanks by our beloved HOD, Dr. Manjunath L. And post that, we will listen to feedback from our students and a few external participants. We sincerely thank all our distinguished speakers, participants, and the organizing team for their dedication and enthusiasm, which have made this FDP a meaningful and successful learning experience for everyone. Thank you, sir. Over to you.
Yeah, thanks a lot, Dr. Gautam, for that brief summary, very quick one, and which has taken all the important points. Now I go over to the participants, and I just now saw the message that Mamata wanted to speak, and she has left. Mamata, are you still there? Okay. We will go to we first take the students, and meanwhile I request Dr. Gautam and Dr. Manjunatha to see whether our resource persons and Sri Nagesh, they have joined, means you can please give them permission to unmute. Now Harsha, please share your feedback. Harsha Angadi, MTech student from NMIT.
Yes, sir. All the participants are now enabled. They can unmute themselves and they can speak, sir.
But the problem will be
we will
seeing
okay.
so
Then
many voices.
Yeah, we'll first. Okay, then I'll mute everyone. I'll one by one. I'll allow.
Yes.
So Harsha will enable now.
Yeah, please. Yeah, if somebody wants to be unmuted, please put the message in the chat box. And the resource persons, if you are there, please put the message in the chat box, because I may not be able to notice you. You have to excuse me for that. And Mr. Nagesh, if you are there, please put the message in the chat box. And now over to you, Harsha.
Sir, am I audible, sir?
Yeah, very much audible.
Sir, hello, everyone. My name is Harsha, second semester MTech Civil. This entire FDP was a really great experience for me because we had live sessions from so many learned professors and sirs from so many places. The main part of this FDP program which helped us was we had speakers who shared their knowledge in such a clear and a practical way, which connected directly to real life industry applications. It helped us to see the subject beyond the textbooks and understanding how things actually work in the field. So I sincerely thank all my teachers, coordinators, and the college for organizing this well useful FDP program. We rarely get opportunities like this with where so many experts come together and share their experience with us. I'm really grateful, sir, for all the efforts made, and thank you very much, sir.
Yeah, thank you, Harsha. And Nandini, are you available? If yes, please go ahead.
Nandini, you unmute yourself and then you speak.
Hello, good afternoon, everyone. I am Nandini, pursuing MTech in Structural Engineering in NMIT Bengaluru. I just wanted to say that being part of this 5 days FTP was really amazing experience. Each session gave us something new to learn, from basic ideas to how steel structures are actually used in real projects. All the speakers were so clear, practical, and shared a lot of information from their own experience, which made the sessions really interesting. It helped us to understand how things work outside textbooks and in the real industry. We got a great opportunity from NMIT to attend this FTP. I, I would like to thank all the professors, coordinators, and experts who made it happen. It was very inspiring and gave us a lot of motivation for our future in structural engineering. And this is all my feedback, and thank you.
Yeah, thank you, Nandini. And our alumnus, one Miss Mamata, is now a PhD scholar in IIT, and she had to leave at 1, and therefore she has given her feedback in the chat box. The faculty development program organized by NMIT Civil Department is exceptionally well planned and highly relevant to current industry practices and research trends in civil and structural engineering. As an alumnus of NMIT, I take great pride in seeing our department consistently deliver such impactful programs. The expert speakers from reputed institutions such as IITs, CSA, SCRC, and leading industries has provided participants with valuable insights into advanced design concepts, modern code provisions, and real-world challenges related to steel towers, industrial structures, and PEB buildings. I extend my sincere appreciation to Professor Manjunath sir for his dedicated efforts in organizing this program despite his busy schedule. I also acknowledge Professor Gautam sir for his constant support of departmental initiatives, and my guide, Professor Raghava sir, whose contributions and efforts have played a significant role in the success of this event. Bringing together such eminent experts from premier institutes, research organizations, and industries is no small feat, and the department deserves great credit for making this possible. This FDP offers students a rare opportunity to engage with renowned professionals and broaden their perspectives. Dear NMIT students, you are in an excellent learning environment. Make the most of these opportunities, as your growth depends on how effectively you utilize them. Thank you, all the organizers, speakers, and participants. Yeah, very kind of you, Mamata. We will write to her and convey our gratitude and thanks. We are proud of her. 1 year back, she completed her MTech from our department, and she did her project work at SCRC, and she was working as project associate here. Now, just 20 days back, she has joined Ocean Engineering Department of IIT Madras for her PhD. Now I go ahead with the other participants who have shown readiness to share their feedback. And meanwhile, resource person Dr. Umesha also has joined here. Yeah. You can give permission for Dr. Umesha to unmute Dr. Manjunatha. Now I go ahead to Dr. Sridhara S., Assistant Professor, Dayanand Sagar Academy of Technology and Management, DSA TM, Bengaluru, to give his valuable feedback. Dr. Sridhara, please, I request Dr. Sridhara SB unmuted.
Sir, you can unmute yourself, sir. Sridhar, sir. Yeah.
Next is Dr. Vadiraj Rao.
Hello, Sridhar, sir. You are now enabled. You can do, you can enable your mic and you can speak, sir. Sridhar, sir, we are audible? Are we audible? Hello?
Is there Manjunatha?
Yeah, he is in the meeting, sir. Yes, he is there.
Then if Vadiraj Rao is ready, we will go to Vadiraj Rao. Meanwhile, you can speak to Dr. Sridhara.
Yes, sir. I'll call him and I'll speak.
Yeah. Vadiraj Rao, can we permit him to unmute?
Yes, sir. I have unmuted. I hope I'm audible.
Yeah, audible. Be a little louder. Please go ahead. And next in the list is Sri B.B. Nagesh. If he is available, if you are available, please put a message in the chat box, Nagesh. That helps us. Yeah, over to Dr. Vadiraj Rao, Assistant Professor, National Institute of Engineering, NIE, Mysore.
Okay, good afternoon, one and all. I'm Vadiraj Rao. I'm working as Assistant Professor in the Department of Civil Engineering, NIE, Mysore. Actually, this is the second FDP that I am attending, which is being organized by Nitya Meenakshi Institute of Technology. I think earlier it was 2 years back with the topic on design of transmission line towers, if I'm right. One thing is very clear, as everybody has told in the feedback session, that the resource persons allocated for all these sessions were exceptional. In fact, they are scientists and experienced professionals having several decades of experience. I must say that their knowledge along with the practical aspects were remarkable. So a wholehearted congratulations for the Department of Civil Engineering in MIT and especially to the organizing team for running this show. And special thanks to Dr. Raghav sir, and I love the way he handles and moderates the session. Overall, it was a very good learning experience that I had in the past 4 days of attending this FDP. Finally, I thank the organizers for giving me this opportunity to express my views and feedback on this. Last but not the least, I think we don't give justice to the knowledge of these resource persons if we do not hear to them in detail and in person. That's what I feel. So the next time we expect an offline FDP of at least 2 days with a similar kind of resource persons. Thank you, sir. Thank you very much.
Yeah, thanks a lot, sir, for your kind words. Very pleasing to hear. And coming to your last sentence, of course, we could get all these resource persons because it was online. And even yesterday, there was some time management required. We could easily do that. This luxury of online is there, and offline, the logistics requirements are too huge. And yes, I have no hesitation. I have all the readiness to get the resource persons and arrange it. We will do that. We take your suggestion very seriously. We will think about it.
Thank you, sir. Thank you.
Yeah, thanks a lot. And now Dr. Sridhara is available. Dr. Manjunatha?
No, sir. I tried to call him. I'm unable to connect to him. Yeah.
Yeah, even Sri Nagesh also is not responding. I will try to call him and see. And next we listen to our colleague, engineer Nagaraj Manjunath, the professor of practice at NMIT, and he has his own design consultancy as well. And he also looks after construction activities. Over to you, Sri Nagaraj.
So thank you very much for this opportunity in the first instance. And I could not attend a few FDPs earlier, but this FDP I managed to sit through all the sessions, and I have found all of them to be extremely useful. I'm basically an RCC man, and if I can put it in a few words, I've started to think and want to get into design of steel structures now. So this is very encouraging, very useful. I have got lots of information and guideline directions in the last 5 days. And design of steel structures has started to excite me in terms of the prospects of design. In terms of the way the FDP was conducted, I think it is fantastic. In different perspectives, such as the timing, the content, the speakers, their experience, invaluable time that they have spent with us. I think this has gone really, really well. Thank you, everybody. Thank you, especially to the speakers. Thank you so much. Over to you, sir.
Yeah, thank you, Sri Nagraj. And I just now see a very detailed feedback from Sujay Raghavendra of Mahe. If you are ready to unmute and tell those things, we allow you. Are you ready? Can we permit the participant to unmute Manjunatha? You see the feedback there. It is there in the chat box.
Yes, sir, he can able to unmute himself.
Yeah, you have no
if
hesitation. We are ready to listen to you, please. You can read in the chat box. I don't know whether is the participant still there?
I think he's there, but I think we
Okay,
can
maybe there
read.
is some issues we will see. Good afternoon, everyone. As we come to the close of this enriching 5-day faculty development program, Dr. Sridhara is there next. We will take that. Yeah, I continue with this. It gives me immediate pleasure to share a few reflections and express our gratitude. Over the past few days, we have collectively explored a wide range of insightful topics, engaged in meaningful discussions, and deepened our understanding of FDP. Each session has brought new perspectives and practical tools that we as educators can take back to our classrooms and institutions. We are incredibly thankful to all our esteemed resource persons and speakers whose expertise and enthusiasm brought depth and clarity to each session. Your contributions have truly elevated this program. A heartfelt thanks to our organizing team and support staff for their seamless coordination and behind-the-scenes efforts that made this FDP a smooth and impactful experience. Let this FDP not be the end, but a stepping stone to continuous learning and professional growth. We look forward to staying connected and seeing how the knowledge gained here translates into meaningful impact. Thank you once again and wishing you all the very best in future endeavors. Thanks a lot, Raghavendra, Sujay Raghavendra. Yeah. Now we go over to Dr. Sridhara. Yes. Dr. Sridhara, please unmute yourself and please go ahead.
Yeah. Thank you, sir. Am I audible, sir?
Yeah, very much, very clear. Please go ahead. We are pleased to see you and listen to you.
Yeah. Good afternoon, all. It's indeed a great opportunity to continue learning analysis and design of steel structures and industrial structures, especially the transmission towers. And at the outset, I thank Dr. Raghava sir for right selection of resource persons to deliver the listed objectives. And here I wholeheartedly declare on behalf of all the participants, all the set objectives, all the set outcomes of this met. Thank you for all the resource persons, starting from Umesha sir and Dr. Rajmane sir and Vishnuvardhan sir and Selvaraj sir and Madhavan sir, and also today Surya Prakash sir. So it is indeed a pleasure to actually listen to all of them. And I thank NITE management and the soft hand behind Gautam Nair sir and our young and raring to go HOD Dr. Manjunath sir for providing this opportunity for PG students, as most of the time Raghava sir used to mention the PG students, the exposure required for the PG students. And also what I saw in all the FDPs is less more of a behavior, means the internal forces and how to actually actually balanced with external reactions and all with connections. It is indeed for NITTE having Surya Prakash sir from, as I heard from Raghava sir, from past 5 years, Surya Prakash sir is actually engaging with NITTE. Is very nice to actually train the faculties, because to deliver, I think the student should be equipped with required attributes of behavior. And one more thing, sir, I like to mention here, this sharing should be continuous. Most of the time, we are not seeing this. I think an NPTEL course, I don't know whether they have tapped into this industry professionals or else academic professionals like Rajmane sir or Umesh sir, Surya Prakash sir and all, giving at least a minimum of 4-week program at NPTEL, because IIT Madras is behind, Kharagpur is behind, so that it should be continued. Not to wait maybe once in a year or 10 years once and all, so that PG students or UG students for that matter, when we talk about SAM and all, if we are actually showing this is only the behavior we are talking about, behavior of structures, about internal forces and all. This will be of immense help so that they can come up with questions in these type of sessions, because I have not seen some PG students and all come up with queries, okay, questions. This is what one thing I actually want to transfer. It is indeed a great session, sir. Thank you so much.
Yeah, thanks a lot, Dr. Sridhara. We will get in touch with you and let us see what we can collectively do and I mean, go ahead together. Next, I go to Dr. Umesha. Dr. Umesha, you can unmute and speak. Before that, any other resource persons are there, please put a message in the chat box so that I will know. Earlier, Dr. Sanat Kumar Rajmane was there. Dr. Manjunatha, you can see whether he is still there. And,
yes, sir, he is there, sir. He is there.
Yeah. After Umesha, I request Dr.
Excuse me,
Rajmane
sir,
to
one
speak.
more. Don't mind.
Yeah, please go ahead.
Dr. Raghava, sir, excuse me, sir. One second, I'll take. Okay, sir. If you don't mind, Sridhar.
Please go ahead.
Sir, actually, after listening to Surya Prakash sir today, actually, what I think this university is to suggest that sir should be honored with an honorary doctorate for Surya Prakash. This is my suggestion. Thank you, sir. Thank you so much. Thank you so much.
Yes, Sri Surya Prakash, you heard it?
Nice suggestion.
Okay. Yeah.
Thank you.
Yes, we all fully endorse your view. We just hope that it becomes reality soon. We wish that.
Sure, sir. Thank you.
Yeah, thank you. And yeah, Dr. Umesha, over to you. We are happy that you have joined, and thanks a lot for coming in the closing session.
Yeah. Thank you very much. Good afternoon to everyone. So it is very nice to see Engineer Surya Prakash, Dr. Sanat Kumar, and Dr. Selvaraj is not there, and Vishnuvardhan also may not be there. So my regards to them. I think they also given a very good lecture. So thank you very much for the opportunity to be here today. I was an honor to serve as a resource person for this faculty development program. I truly enjoyed interacting with the vibrant group of faculty and students overall insights on this sustainable work. So I hope the session was informative and also sparking some new ideas or perspective for you to explore further in your academic as well as the research journey. If there is any follow-up questions or discussions you would like to continue, I would be happy to connect. And once again, my sincere thanks to the organizers, especially Raghava and his group, and coordinators also there, Manjunatha, and most of them are very senior faculty in NITTE University. And also, I would like to thank all the participants for their warm welcome and excellent listening to throughout the session. I used to see all the more than 65 members are there. I think this is a very good faculty development program arranged by NITTE. I think if you have the online program, most of them will not be there. They'll log in and go. But here it is not like that. They are actively participated in this FDP program.
it's a very excellent arrangement, and also active participation is very good. And wishing you all the best for the rest of FTP and our professional endeavors. Thank you very much, Raghva, for giving this opportunity. And nice to see you all, I think, including our Rajmane and Surya Prakash and Manjunatha. Everybody is here. I think very nice. Thank you. Thank you very much, Raghva. I think I will.
Yeah, thanks a lot,
Yeah.
Dr. Umesh. I was telling Sri Surya Prakash about our IIT days. Therefore, after this closing session, if you still have time, you can stay back and you can have a quick chat with him. And also, Nagesh also might be there, and Sanat Kumar Rajmane is here. Okay, and I just now see in the chat box an excellent message once again from one Shipa N, Assistant Professor, Mohandas College of Engineering. And if the participant is ready, we can unmute her. Otherwise, we will go ahead. Shifa, do you want to speak? Or some of them, as the other participant told, they will be in meeting, etc. Yeah, no, they have put. Yeah, but anyway, we are very grateful to you for your message. We take the essence and we will see what best we can do. And yeah, next is Sanat Kumar Rajmane, and I will just take 2 minutes since I read all other messages. I don't want to disappoint Shifa. I will quickly read this message also. This is Shifa N, working as assistant professor in Mohandas College of Engineering and Technology, Thiruvananthapuram, Kerala. Thank you for organizing such a comprehensive and insightful FDP on steel structures. The program was well structured and the sessions were engaging and informative. The expert speakers shared valuable knowledge and practical experiences, which will greatly benefit our teaching and research endeavor. The FDP provided an excellent opportunity to network with industry experts, fostering potential collaborations and exchange of ideas. We are grateful for the support and resources provided, which enabled us to enhance our understanding of steel structures and their applications. We look forward to implementing the learnings from this FDP in our academic and research pursuits, and we appreciate the efforts of the organizers in making this program a success. Thank you, NMIT. So kind of you, Shifa, and we are grateful to you. And now, Dr. Rajmane, please, you can unmute and you can have your camera on. We will see you, and you can go ahead.
Dr. Raghav, sir, my camera is almost on. Couple of minutes back only.
Now I'm able to see you.
You're not seeing.
Yeah. I'm
Anyway,
sorry.
thank you very much. No,
Unless
okay.
it comes
Thank
here,
you
I will not be able to see. Yeah. Please go ahead.
Okay. First of all, thank you very much for allowing me to join this program. And I attended most of the lectures. Earlier, I was not doing like that, but here I found every lecture was very interesting. In fact, Umesh, I met him a couple of years back. I don't remember, more than, I think, 6 or 7 years it seems. But his lecture was very interesting. Surya Prakash, please switch on your video. Many times I have met him, but I never heard about his lecture. Today I could listen to his lecture and all. It is very interesting, very nice. Thank you very much to allow me to listen to you. Today, in fact, because of his lecture, I wanted to join. I very in the beginning itself. You have not seen me anyway. Raghav sir has not seen me. It's okay. From my side, this program is very nice arrangements for the students, especially those who have come out of the education and joining for the field. It will be very helpful. Of course, to the faculty also, it will help them to update the subject implementation in the field. I came to know that every year this kind of lecture is conducted by the Tech College. Actually, students learn only some basics about the subject, but they may not be able to know how to apply them in the field. Please also we should know that in the program, the lectures are also given very limited about the subject speaking. So because of that, it will be very difficult for them to explain about the subject in depth. But these lectures will inspire all the people to learn about the subject and understand it so that how to use it in professional practice. It is very nice. Thank you very much for this program and allowing me to join to the Inte College and all the team. Thank you very much. Thank you.
Yeah. Yeah.
Good afternoon,
Thanks a lot.
Umesh sir and Rajmane sir. Very nice seeing you both after.
Yeah. Thank you, Surya Prakash. I think it's very nice to see you also.
Thank
So
Raghav
every year
sir,
I used to see you. Okay.
this
Online
great
only.
opportunity.
Yeah, only
Keep
Nagesh
your
is missing.
videos
He had
on.
told he will join. Yeah.
Nagesh, also,
Fine.
I require everybody to switch on your videos at least.
Yeah, that
Yeah,
we
We may
will
not be
do.
able to meet.
I'm sorry, we should have done that a little earlier when many others were there. Before we go to the next program, I request all the participants to switch on their video so that we take the screenshot, which is also required for our documentation also. Please, sir. All the participants, please quickly your video on, cameras on.
Raghav, Surya Prakash also maybe wants to talk. Just
Yeah. After this, we will do that. Yeah.
Okay.
Thank you.
Okay.
Shri Surya Prakash, immediately after this, we will have remarks from you, and then we will go to vote of thanks.
Sure, sir.
Yes, sir. Done, sir.
Yeah, thanks a lot. And over to you, Shri Surya Prakash, for your closing remarks.
Thank you, Dr. Raghava sir, and it's a really pleasure meeting Umesha ji and Rajmane sir. And we have spent days together in IIT, years together. And it's a nice experience again meeting them in this FDP. In fact, it's been my pleasure associating with NITE for these FDP programs. In fact, he has so much confidence in me that every time he calls and I can't say no, because sharing with FDP, I feel we can reach out to more students, because whatever knowledge we share with faculty, they'll be transferring it to the student. So it will be very helpful for us also, that knowledge that we gain from the society, we give it back to society, particularly for the future. And I have seen all the resource people last 5 days are all experts in the respective fields, actually. Probably I'm the only person with a pure practical background only, no research experience other than my IIT Master of Science by Research. But I always try to implement some new technologies and new methods. We have developed certain new methods and presented. So I shared whatever experiences we have gained in the industries today, particularly. And I hope that will be useful for the faculty. And they can also guide some projects, practical projects to the student. I can help them with the inputs required whenever they need, actually. So I once again thank Dr. Raghava Manjunath for giving me this opportunity, and look forward to associating with you in future. And I especially thank Dr. Sridhara for proposing a doctorate, which has been my dream. So I'm not able to pursue research because of my time constraint, but definitely the works I have done can be part of any thesis, actually. So I thank you, sir, for giving me this opportunity, and very happy to have met with all these student professors. Thank you very much.
Thank you, sir. Thank you so much.
Yeah, thank you, Shri Surya Prakash and Dr. Manjunatha. Now it's over to you. Before that, in case we have missed any point, you and Dr. Gautam can feel free to point it out. Otherwise, you can go ahead with proposing the vote of thanks and closing.
Yeah, thank you very much, sir. It gives me immense pleasure and indeed a sense of gratitude to deliver vote of thanks on behalf of Department of Civil Engineering, Meenakshi Institute of Technology. So good afternoon, everyone. So at the successful conclusion of this 5-day online faculty development program on advanced analysis, design, and design of steel towers and industrial structures from 21st to 25th July 2025. First and foremost, I extend my heartfelt thanks to our Chief Patrons, Sri N. Vinay Hegde, President, Nitte Education Trust, and Professor N.R. Shetty, Senior Advisor, Nitte Education Trust, for their constant encouragement and visionary leadership. I also take this opportunity to thank Mr. Rohit Punja sir, Administrator, Nitte Education Trust, for his continued administrative support and facilitating this event, which played a crucial role in organizing this FDP successfully. Our sincere thanks to Dr. Sandeep Shastri sir, Vice President, Bengaluru Campus, Dr. H.C. Nagraj, Principal, NMIT, and Dr. Sudhir Reddy, Director, Curriculum Development, for their valuable guidance and academic support throughout this program. I would like to express my deep appreciation to eminent resource persons who enriched the FDP through their insightful and engaging sessions. I thank Dr. P.K. Umesha sir, Professor, Department of Civil Engineering, Vidyavardhaka College of Engineering, Mysuru, former Chief Scientist, CSIR, Structural Engineering Research Center, Chennai, for delivering an excellent and insightful session on structural analysis of telecom towers, which helped participants to gain a practical understanding of real-world design challenges. Thank you, sir, Umesh sir. I thank Dr. Sanat Kumar Rajamani sir, Professor of Practice and Advisor, Civil and Infrastructure Engineering, IIT Dharwad, for his comprehensive talk on steel warehouse planning and design, combining both academic and field perspective in an effective manner, sir. I thank you, sir, from my whole heart. I thank Dr. S. Vishnuvardhan, sir, Senior Principal Scientist, Fatigue and Fracture Laboratory, CSIR Structural Engineering Research Center, Chennai, for his enlightening session on fatigue and fracture mechanics in steel structures, which was highly appreciated for his technical knowledge in deep. And so I thank Dr. Mahendra Kumar Madhavan, sir, Professor, Department of Civil Engineering, Dean Alumni and Corporate Relations, IIT Hyderabad, for elaborating on pre-engineered buildings planning and bridging the gap between the structural systems and site execution. I thank Dr. M. Selvaraj sir, Joint Director, Head of the Department Division, Mechanical Engineering, Central Power Research Institute, Bengaluru, for his detailed session on design and testing of power transmission towers, which introduced participants to cutting-edge testing methods and practical applications. I thank Engineer P. Surya Prakash sir, Founder and Managing Director, Satyavani Projects and Consultants Private Limited, Hyderabad, for presenting insightful case studies from industry, which added a practical dimension to our discussions and highlighted the real implications of design principles. Thank you very much, sir, for your valuable time. And though you were traveling, so you are able to give the presentation with sitting in your car. So that is very much appreciated, sir. Thank you very much, sir. I also thank all participants who gave their valuable voice feedback at the end of the session today, for their thought about this program. Thank you, everyone. I'm very much grateful to G. Raghava sir, Dr. G. Raghava sir, Professor, Department of Civil Engineering, NMIT, and he is the main convener of this FDP program. He is the Professor, Department of Civil Engineering. His continuous involvement and meticulous planning in terms of deciding the title of the, starting from the deciding the title of the project, this FDP, even contacting the speakers, continuously communicating with them, fixing the time slots, and also hosting this FDP without any hazards seamlessly. That was really very nice, sir. I'm very thankful, sir. Raghav, sir. My sincere thanks to Engineer Nagaraj Manjunath, sir, Professor Practice, Department of Civil Engineering, for his support in organizing this FDP. I also thank Dr. Pratima Ji, Deputy HOD, Department of Civil Engineering, for her constant support in organizing this online FDP. I also thank all the faculty coordinators, faculty who had introduced our eminent speakers on each day. I thank everyone. A special appreciation to our faculty coordinator, Dr. Gautam S. Nair, PG coordinator, Department of Civil Engineering, for his involvement for getting approvals for the program and coordinating this event very smoothly and communicating with all the participants for the meeting links and sharing the feedback links, everything in all respects. Thank you, everyone. Thank you, sir. A big thanks to all the participants from the academia, research, from design, participating engineers and postgraduate students. That is our students who have joined all the sessions, because this is one of the subjects for them and it is mandatory for them. So I thank them also for their involvement, and all the participants from outside also who joined. We are very much thankful to you all. Your active engagement made this FDP a vibrant and a meaningful learning experience. So finally, I express my sincere appreciations to all the technical and administrative staff for their behind the scenes effort in ensuring smooth conduct of this FDP. So let us continue to collaborate and innovate as a community of learners and professionals committed to the advancements of civil engineering. Thank you, one and all. Thank you once again.
Yeah, Dr. Manjunatha, thank you, and all of us join in thanking you, head of the department, and who has been the main backbone of this program. Okay, thank you.
Thank you.
Thank you, sir. Thank you, sir. It's pleasure.
Yeah,
It's my duty.
Yeah, anything else, Dr. Manjunatha?
That's all, sir. This is my duty and my responsibility. So I had to do. And this kind of program, as we all know, that every year we are doing it, and we continue to do every semester as well. So I hope all the resource persons, I mean experts, will support us in future FDPs also, sir.
Yeah, with that we are formally closing this program, but you can keep the stream on for some people to chat if they want for another 5 minutes. And I request Dr. Manjunatha and Dr. Gautam to see the messages in the chat box, whether you want to copy paste or whether it will be available for retrieval. I leave it to you to decide. With this, I thank everyone who is still present here, and I formally declare this FDP closed. Thanks everyone, and we are leaving now. We will meet shortly sometime somewhere soon. Namaste.
Namaste.
Thank you, everyone. Thank you.
Yeah, ಹೇಳಿ ಉಮೇಶ, ಹೇಗಿದ್ದೀರಿ? ರಾಜಮಾನೆ.
ಆರಾಮಪ್ಪ, ಆರಾಮಾಗಿದ್ದೀವಿ. ನೀವು ಹೇಗಿದ್ದೀರಾ?
ಫಸ್ಟ್ ಕ್ಲಾಸ್.
ರಾಜಮಾನೆ ಹೇಗಿದ್ದಾರಾ? ಸೂರ್ಯಪ್ರಕಾಶ್, ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ಎಲ್ಲಿ ಹೊರಟೋದ್ರು ಅವರು. Gautam Nair, I think he's there. Manjunatha is there. So thank you for all of them.
You know B.V. Nagesh also, right, Umesha?
Yeah, I know him. He is there?
Yeah, he had told he will join, but unfortunately he didn't. I checked. I sent a message also.
Okay, I think he is not joined. Rajmane, ಹೇಗಿದ್ದೀರಾ?
ಫಸ್ಟ್ ಕ್ಲಾಸ್.
ನಮಸ್ಕಾರ. ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಆಗಿದ್ದೀರಾ?
ರಾಜಮನೆ, ನೀವು ಹೇಳ್ತಾ ಇರೋ ತಪ್ಪು. ನೀವು ಫಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲ, ಸೂಪರ್ ಕ್ಲಾಸ್.
ಸೂಪರ್ ಕ್ಲಾಸ್ ಅವರಿಗೆ.
ಅದೇ ವರ್ಡ್ ಯೂಸ್ ಮಾಡು.
Okay.
Yeah, Dr. Sridhara, if you are still available, we will coordinate and do something together, Dr. Sridhara. I saw your message just now.
I think he might have left.
Namaste.
ನಮಸ್ಕಾರ ಆಯ್ತಾ?
ಸಿಗೋಣ.
ಆಯ್ತಪ್ಪ, ಇನ್ನೇನು ಸಮಾಚಾರ ಹೇಳಿ.
ಸಿಗೋಣ ಮತ್ತೆ.
ಆಯ್ತು.
Dr. Sridhara, ಇದ್ದೀರಾ?
He might have left.
Okay.
ಇನ್ನೇನಪ್ಪ ರಾಘವ ಸಮಾಚಾರ?
ಏನಿಲ್ಲಪ್ಪ ನನ್ನ ಕಡೆಯಿಂದ
ಚೆನ್ನಾಗಿ
ಏನಿಲ್ಲ.
ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದೀರಾ ಎಲ್ಲಾರು. ಇಟ್ಸ್ everybody appreciated. I think I would like to congratulate once again. I think it is very nice program.
But it takes a lot of effort, Umesh. ಇದು every semester ಇದು ಮಾಡ್ತೀನಿ ಮತ್ತೆ ರಿಹಬಿಲಿಟೇಷನ್ ಪುಟ್ಟಿಂಗ್ ನೆಕ್ಸ್ಟ್ ಸೆಮಿಸ್ಟರ್ ಮಾಡ್ತೀನಿ. Because it will be helpful to our PG students also.
Okay.
But I do not know how long I will be able to do it. Okay, noted.
Yeah, you can do it. You can do it, no problem.
Sir, good afternoon.
Yarappa?
Sir, I'm Dr. Vishwanath. Where Dr. Sridhar is working, I'm heading the Department of Civil at Dhananand Sagar College. Yeah, I was
Namaste,
there
Dr.
in the line.
Vishwanath. If
Yes,
okay
Dr.
with you,
Vishwanath.
please have the camera on. I have not seen you, or I must have seen you and.
ನೋಡಿದೀವಿ ಸರ್ ಹೀಗೆ ನಮಸ್ತೆ ಸರ್.
ನಮಸ್ಕಾರ.
Namaste. Yeah.
ನಮಸ್ಕಾರ.
I was there through and through, sir. Our Sridhar just now he left in examination work anta. So ಹೇಳಿದಕ್ಕೆ just wanted to continue because that will be there and we will definitely meet you, sir, and catch up with you, and we would like to continue what Sridhar has told. In fact, we want that.
See, I was just telling Dr. Manjunath also, even Umesha is here again, he is also from Vidyavardhaka, Mysuru. See, taking into consideration all the pluses and minuses and the limitations we at institution levels may have, let us still find out some ways of joining together and making some programs together.
Definitely, sir, definitely.
Yeah, that we can do it. Yeah, that's fine.
Yeah, definitely, sir, definitely.
ಮತ್ತೆ Dr. Vishwanath avare, just 1 minute, and one more thing I want to tell you is, ನನಗೆ Dr. Umesh age ಎಲ್ಲ we are all retired people, and Dr. Rajmani also will join us shortly. He is a little younger than us, therefore we are at an age where we eagerly wish to give back whatever we can. And you youngsters can make use of us. And as you know, there are so many who do not say no to us, join us, give their support, and we can see how best that can be made use of.
Sure.
Okay.
Definitely.
Adu nodi, and what I was doing last 5 years in NMIT is, MTech ಗೆ ಒಂದು ಸೆಮಿಸ್ಟರ್ ನಮ್ದು ರಿಟ್ರೋ ಫಿಟ್ಟಿಂಗ್ ರಿಹಬಿಲಿಟೇಷನ್ ರಿಪೇರ್ ಆ ಸಬ್ಜೆಕ್ಟ್ ಬರುತ್ತೆ, ಇನ್ನೊಂದು ಸೆಮಿಸ್ಟರ್ ಅಡ್ವಾನ್ಸ್ ಡಿಸೈನ್ ಆಫ್ ಸ್ಟೀಲ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಬರುತ್ತೆ. ಈ ಎರಡು ಸಬ್ಜೆಕ್ಟ್ ನಾನು ತಗೊಂತೀನಿ, ಅಂಡ್ ಇನ್ ದೀಸ್ ಲೈನ್ಸ್ ಐ ಆಮ್ ಅರೇಂಜಿಂಗ್ ದೀಸ್ FDPs every year. Therefore 2 every year, and known resource persons, and generally we are very fortunate to have very good, excellent resource persons, and as an online program it is going on well. Only thing is enormous effort is required, and till now we have done, and that's what I was telling Umesha now. I do not know how long I can do it, and ಸ್ವಲ್ಪ logistic support ಬೇರೆಯವರಿಂದ youngsters ಇಂದ ಸಿಕ್ಕಿದ್ರೆ the main part I am still ready to do, and we can keep going ahead.
Kandita, sir. Kandita. Thanks for your so encouraging words and supporting, sir. We need. So ಪ್ರತಿ ವರ್ಷ Engineers Day and World Environment Day ಎಲ್ಲ ಮಾಡ್ತಿರ್ತೀವಿ, sir. I mean, I invite experts like you people, and we have a 1-day workshop ಮಕ್ಕಳಿಗೆಲ್ಲ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So we'll again join with you, and we need your guidance and support. So we will do, sir, together.
Okay.
Yeah.
Good.
Okay, we will meet again. Okay, Dr. Vishwanath, we will meet sometime soon. Very nice connecting to you, and Dr. Sridhar avargu heli.
Yeah, Kandita, sir. I'll message. Even I know Manjunath Yell also very well for the last 15 years, 20 years. We know each other.
Yeah,
Yes,
he's
sir.
a
Good
very,
afternoon,
very
sir.
affectionate person, and he has become very close to me after I joined NMIT. ಅವ್ರಿಗೆಲ್ಲ ನನ್ನ ಮಕ್ಕಳು ವಯಸ್ಸು.
Okay. Vishwanath sir, thank you very much, sir, for joining and sharing your points, valuable points. Definitely, whatever you are discussing, we'll take it forward. Yeah.
Thank you, Manjunath sir. Thank you. Nice of you.
ಓಕೆ ಅಪ್ಪ, ಕ್ಲೋಸ್ ಮಾಡೋಣ. ಮಂಜುನಾಥ, ಇದು ಮೆಸೇಜ್ಗಳು ಇರುತ್ತಾ, ಆಮೇಲೆ ಕಟ್ ಪೇಸ್ಟ್ ಮಾಡಬಹುದಾ?
Yes, sir. Definitely ಇರುತ್ತೆ, ಅದೆಲ್ಲ ಇರುತ್ತೆ.
Okay, thank you. Some messages are good. We may need them for documentation.
Yeah,
Okay.
it will be there, sir. They will be there, sir.
ಓಕೆ ಉಮೇಶ ಸಿಗ್ತೀನಿ.
ಓಕೆಪ್ಪ. ಓಕೆ ನೋಡೋಣ. ಓಕೆ ಬಾಯ್.
ಓಕೆ ಮನೇಲಿ
ಓಕೆ
ಕೇಳಿದೆ
ಮಂಜುನಾಥ, ಥ್ಯಾಂಕ್ ಯು ಮಂಜುನಾಥ. ಓಕೆ
ಬನ್ನಿ
sir,
NMIT
thank you,
ಒಂದು
sir.
ಪ್ರೋಗ್ರಾಮ್ ಹಾಕಿ NMIT-ಗೆ.
ಆಯ್ತು ಬರೋಣ.
ಶ್ರೇಯಸ್ ಗೆಡ್ಲ ಕರೀರಿ ಅಂತ.
ಅವ್ರದ್ದು ಯಾವಾಗಿದೆಯಂತೆ ಅವ್ರಿಗೆ ಕಾಂಪ್ರೆನ್ಸಿವ್ ವೈವಾ?
ಮಾಡ್ಕೊಳ್ಳಿ ಸದ್ಯದಲ್ಲೇ ಅನ್ನೋಣ, ಇಲ್ಲ ಅಂದ್ರೆ DC ಮೀಟಿಂಗು.
DC ಮೀಟಿಂಗ್ ಇರುತ್ತೆ, ಯಾವ್ದಾರ ಒಂದು ನೋಡೋಣ. ಹೇಳ್ತೀನಿ, ಕೇಳಿ ನೋಡ್ತೀನಿ ಅವ್ರಿಗೆ.
We will see some occasion. Okay.
Okay,
ಉಮೇಶ್, thank you. Bye.
Bye.
ಬರ್ತೀನಿ ರಾಜ್ಮನೆ, ನೀವಿನ್ನ ಇದ್ರೆ.
Rajmani sir has left, sir.
Yeah, sir is not there, sir.
Okay.
Sir, yes, sir. I think with your permission, Raghav sir, or sir, I think he is also left.
Yes, left.
So, shall we close, sir? Gautam sir, we'll end
Yes,
the
sir.
meeting.
Yeah.